Okay, we want to look at this very situation on the board. Rationalize a denominator of a fraction we saw as denominator. Now, the question is this: when do we actually rationalize? We rationalize whenever we have a fraction. Okay, that is a division of sort. Division of sort. Whenever we have a fraction, we rationalize so that the denominator contains a sort. Okay, so that the denominator contains a sort. That is, the fraction we have, the denominator of that fraction must contain a sort. A situation like this, we cannot rationalize. Root A over B. Look at B does not have a root. There is no root on B. Therefore, it's not a sort. Okay, now we cannot rationalize in this very case. But for this, since there is a root on B, and the B is a denominator, and it is a sort, coming as a denominator, therefore we rationalize. We simply use the denominator, like the sort, which is the denominator here, to multiply the fraction. And become root A over root B times root B over root B. Now the head taking a single root, we have to multiply A and B, become this, that is A times B, okay, and also taking a single root here, become B times B. Now if you do this very one, the numerator, we have AB, that's A times B is AB. While for this one, we have B squared, root B squared. Now don't forget that square with key root, therefore we have root AB over B. Therefore, can you see, we have rationalized and we now have we're having a perfect square, we're having a rational number when we rationalize. Okay, that is to say now, for this one, initially we're having a sort, but at the end of it, there is the final solution, there was no root again. Meaning there is this one as a denominator, here it is not a sort. That is for this one, we are not having a sort. Okay, that's what we do when we are dealing with this very case. When we are rationalizing a sort, there is a fraction with sort. Whenever we are rationalizing fraction with sort, this is what we do. Please take note, this is what we do. Okay, now, another thing we also do again under this very aspect. Okay, let me have this very one. Let me give you a situation like this. Okay, let me give you a situation like this. Now, for this one, we also rationalize. Look at it. The denominator here is also a sort. Look at it. But the A is not a sort, but the denominator is a sort. As far as the denominator is a sort, we rationalize. Therefore, we also use the sort here, which is the denominator, the root of B, to multiply the fraction. Become what? A over root B times root B over root B. Therefore, when I multiply here, now remember we have taken a rule like this before. A times root B. See, this one does not have roots. It becomes A root B. Okay, now let us see the next thing there. Okay, let us see the one under. Here become roots. This one become B times B, become B squared. And this square here can keep this. We have what? A root B over B. This one becomes your final solution. Okay, another one again we have. Let me call this one 1. Let me call this one 2. Another one we have again is this. Let me give you this one. We have A over root A, okay, plus root B. This one is another one. Now, what can we do here? Whenever we have something like this, do you see that under we still have a sort? Because look at it, we have root A and root B, but there's an addition between them. For this one and 2, we have a single sort, but for this one we have two sorts. Now, whenever you have a situation like this, as far as still a fraction, and we have to solve number, and it's connected with addition, what do? We simply take the conjugate of the denominator. Now, what is the conjugate of this very one? The conjugate of this one is going to be negative. That is saying A minus root B. Therefore, I will use that conjugate to rationalize the fraction. That is to say A over root A, okay, plus root B. This is the original fraction. I will now take the conjugate of this one. The conjugate of this one is root A minus root B. I will use to multiply the fraction called A minus root B. Okay, all over root A minus root B. I will simply take the conjugate here. After taking it, I will use to multiply the fraction. That is what I have here now. Now, for this one, I will multiply, become A. Okay, we're having two things here, become root A minus root B. Okay, all over, for this one, we also have two things, root A plus root B. Okay, okay. Now we have another one again, root A. We have another one, root A. Okay, we have root A minus root B, root B. Okay, now let us see what we need to do there. Okay, for this one, I think this one cannot be simplified. One up cannot be simplified. I will simply leave it as root A. Okay, A, open bracket root A minus root B. I'm leaving like this. For this one, remember we have to expand. This one is not the difference of 2 squared. I will take the difference of 2 squared there. Yes. For this one, we have to take, this one is a difference of 2 squared, of course. This one is a difference of 2 squared. You know that for this one, which is difference of 2 squared, for this very one, it will produce something like this when you expand it. This when you expand this very one here, when you expand these two things, okay, we are going to have root A squared minus roots, it will be root B squared. Okay, that is what we are going to have at the end. It means that for this one here, this square here will kill this root, this square here will kill this root. Now, what's going to be the final result? The final result will be, this is what we are going to have. We have A, okay, open bracket A, root A minus root B, okay, all over A minus B. This will be the final solution. This one will be the final solution. This very one will be the final solution. From here, we are going to have this. Okay, this is all about this aspect. Now, if I also have, this one was an addition. This one was an addition. That is the denominator here with A plus with B. One connecting it, the sign connecting is an addition. The same thing also applies to minus. If for example, I have something like this, something like this. That you say we have, A all over root A minus root B. That would be, we also do the same thing, meaning we simply take the conjugates. We also take the conjugates of the denominator. As far the denominator here is the sum, we also rationalize. Okay, to rationalize, first and foremost, what do you do? Take the conjugate of the denominator. The first thing that will come to your mind, take the conjugate of the denominator. Taking the conjugate of this one is simply mean root A plus root B. Okay, use that conjugate now to rationalize the fraction. That is, it become A all over root A minus root B. Okay, used to multiply the fraction become, like I say, this one is not giving us this now. Okay, become root A plus root B, that is the conjugate, and also root A plus root B, that is the conjugate. Okay, now you multiply this one, we're going to still have A, okay, open bracket, okay, we have A, open bracket, root A plus root B, okay, now we have under, okay, we still have difference of 2 square under, okay, root A minus root B, okay, we have another one, root A plus root B. This one is difference of 2 square. Now we can expand it, when you say expand, the same thing here, the same way I did this one, and at the end we are going to have A, okay, root A plus root B, okay, and at the end, remember we have something, we have done something like this before. Look at it, we have A minus B. That is going to be the final solution there. Okay, please, I think at this moment, we can stop here. We have already resolved this aspect. Okay, now, I think we can use a number to represent this. Can we use a number to represent? Okay, I will consider that one in my next class. I will consider that one. I'm going to use a number to represent this very aspect. This one I've just done, A and B. I will use a number and integer to represent, and we will solve it. Please, that one will be considered in my next class. Please don't forget to like my page, JB Jungle Online Mathematics, and also subscribe to my YouTube channel, Mathematics Science in the Garden Tutorial. All the best.